Good afternoon and welcome to week 11 of problem solving sessions for the course on data science, essentials of data science with our software. I am Shreya, one of the TAs for the course, and I hope you can hear me. Am I audible? Is the screen visible? Can you please reply? Alright. Okay. Alright. So, can you please unmute yourself and ask me your particular doubt, since there's nobody else? I think we can have this conversation. It'll be easier for me to toggle and navigate also. Yes, you want me to explain estimators. What in particular about estimators do you want to know?
मैम जैसे कि एक क्वेश्चन था असाइनमेंट में
Hmm.
क्वेश्चन नंबर 8
Okay. This week 11 assignment?
मैम वीक 10
Week 10 assignment. Okay. Let me go. Question number 10.
मैम क्वेश्चन नंबर 8
Okay, question number 8. Okay. Yes, huh. So you want me to solve question number 8?
मैम बेसिक प्रोसीजर क्या होता है कि मतलब कैसे क्वेश्चन को अटेम्प्ट करना होता है, मुझे वो समझ नहीं आया इसमें। मैं मीन का निकाल लेता हूँ एस्टिमेटर कि मतलब
Okay.
मीन
हाँ.
इज यूज्ड एज एन एस्टिमेटर और नॉट, बट मेरा वेरिएंस का नहीं आ रहा है।
Okay. ठीक है. Let us try to solve this. To to check for unbiasedness, what we have to do? We have to do expectation of same process. Expectation of s square. We have to show that is equal to sigma square. Okay. Now. Okay. So this is week 10. Question number 8. x1 x2, consider sample variance s square. Okay. x and iid follows some mu sigma square, and we are given s square equal to 1 by n minus 1 summation xi minus x bar whole square, I equal to 1 to n. And they are saying we have to find out whether to show that s square is an unbiased estimator of 8. So we have to show expectation of s square equal to sigma square, right? इसको how to tackle you are not able to understand.
यस हाँ
Okay.
मैम, लाइक मैंने इसमें ये लॉजिक लगाया कि जो सैंपल मीन है वो एक अनबायस्ड, वो बेसिकली म्यू के बराबर है।
हाँ.
और जो पॉपुलेशन वेरिएंस होता है दैट इज बेसिकली 1 अपॉन में n समेशन i इक्वल टू 1 से n तक xi माइनस म्यू का होल स्क्वायर। एंड सिमिलरली बेसिकली तो जो सैंपल का वेरिएंस है वो भी सिमिलर पैटर्न ही होना चाहिए, बट
The catch here is, here you see we are estimating once x bar is estimated, you already, I mean, how do I put it, this, if since this is already fixed, we can only go up to xn minus 1. The rest is fixed by x bar. So that is the reason we have n minus 1 in our what do I say, denominator.
Can you
Yeah,
please explain?
yes. So here what we have to do is, so here if we take expectation of x square, let's say s square, so this one we can write as, one second, why is my pen not working? You can write this as 1 by n minus 1 summation I equal to 1 to n expectation of xi minus x bar square. Where is this? One second. Okay. So this one we can write as 1 by n minus 1 summation I equal to 1 to n expectation of xi square minus, or rather let's say if I just minus mu plus mu minus x bar whole square. Okay, so abhi this we can write as 1 by n minus 1 summation I equal to 1 to n expectation of xi minus mu plus mu minus x bar whole square. Okay, so this is 1 by n minus 1 summation I equal to 1 to n expectation of xi minus mu whole square plus mu minus x bar whole square plus 2 xi minus mu into mu minus x bar. Is it okay?
Yes, ma'am.
Okay, now this one we can write as 1 by n minus 1 summation I equal to 1 to n expectation of xi minus mu whole square plus expectation of mu minus x bar whole square plus 2 expectation of xi minus mu into mu minus x bar. Okay, one second. There's no need to introduce mu here. We can directly solve from here. Just a minute. This is creating problems here now. let's say this is what we need to prove. Now let us find out this thing first. Summation xi minus x bar whole square, expectation of this thing. Okay, so this one we can write as expectation of summation xi square minus summation 2 into x bar into 2 into x bar into xi plus x bar square. Okay, this one we can write expectation of summation xi square minus, so everything is within summation. If we take summation in xi inside, then this will be 2 x bar into nx bar plus nx bar square. Do you agree with me? This is I equal to 1 to n, this is I equal to 1 to n, this is. So here if we take x bar 2 and x bar outside, summation xi can be written as n into x bar. Okay, because x bar is summation xi by n. Is it okay, clear? And
yes ma'am.
And this one x bar square we can write as n into x bar square. So this thing we can write as expectation of summation xi square I equal to 1 to n minus n x bar square. Up till now this much is clear, right? Okay.
Yes ma'am.
Now we'll take expectation inside. So we'll write this as summation I equal to 1 to n expectation of xi minus n we can take like this, expectation of x bar square. This much is okay? This is clear?
Yes ma'am.
Okay. Then right, so we have summation I equal to 1 to n expectation of xi, and here we have minus n expectation of x bar square. Now xi expectation is how much? This is mu, and xi follows some mu and sigma square, then x bar will follow mu and sigma square by n. This is clear? Because expectation of x bar is okay, 1 by n summation xi expectation of this thing. So we'll have 1 by x summation expectation of xi. So this will be 1 by n into n mu. So we have mu. So this is clear. And variance of x bar is variance of 1 by n summation xi. So 1 by n square will come out when we take it like this, and we have variance of summation xi, and that will be equal to summation of variance of xi since xi's are independent. Okay, there is no covariance term. Variance of ax plus by equal to a square variance x plus b square variance y plus 2ab covariance of x and y. This is the generalized formula. Okay, but this term will be 0 if x and y are independent. Okay, so similarly, since there are no covariant terms between xi's, as xi's are, it is already given, it is a random sample, so it means it is IID, independent and identically distributed. So we will not have cross product terms. Therefore variance of summation xi we can write as 1 by n summation of variance of xi. So this will be how much? 1 by n square into n sigma square. So we'll have sigma square by n. Thus this formula. Okay. So now, is this clear? Or any doubt if you have, please tell me.
I'm like, जो ये procedure है ये हर एक question में ऐसे ही होगा?
हाँ, हर एक क्वेश्चन में you just have to do an expectation of मतलब हाँ, this is the procedure. If you are given something, you have to write the equation and take expectation. Try to reduce it in form so that it resembles some of the known results that can be readily used. Okay. So यहाँ तक it is clear, I hope. यहाँ तक. Where is this thing? Okay. Up till here it is clear, right? Then to derive this, what is needed is this formula, this one and this one. Okay. So now how will I do that? Here we want summation I equal to 1 to n expectation of xi, and here we have, sorry, summation not xi but xi square. Xi square minus n x bar square. This is what we want. So here we'll write xi square minus n expectation of x bar square. Now xi follows normal mu, not normal, it's not given normal, mu sigma square. So variance of xi is, it can be written as expectation of xi square minus expectation of xi whole square. So this one we can write sigma square equal to expectation of xi square minus expectation of xi is mu, that is mu square. Therefore from here we have expectation of xi square equal to sigma square plus mu square. Alright, and from this result x bar follows mu sigma square by n. We have variance of x bar equal to sigma square by n. So we can write it expectation of x bar square minus expectation of x bar whole square equal to sigma square by n. So expectation of x bar square will be sigma square by n plus mu square. Okay. So then we are going to substitute this value and this value in this equation. Okay. So then what do we get? We want summation I equal to 1 to n expectation of xi square minus n expectation of x bar square. So let us put this summation I equal to 1 to n. Expectation of xi square is sigma square plus mu square minus n into expectation of x bar square is how much? Sigma square by n plus mu square. So this will be n sigma square plus n mu square minus sigma square minus n mu square. So n mu square will cancel. Sigma square if we take common, then we have n minus 1 sigma square. Okay. So then we started with what? We started with this equation, expectation of this. So what do we have? We have expectation of summation xi minus x bar whole square to be equal to n minus 1 sigma square. So then one expectation of 1 by n summation n minus 1 summation xi minus x bar whole square, that would be equal to sigma square. Okay, so we have expectation of s square as sigma square, and s square is unbiased for sigma square. Is it okay? Did you understand how to do it? So these two, whenever you have some square terms, expectation of square, you have to write it in terms of variance, because the formula for variance is this one. Variance of xi equal to expectation of xi xi square minus expectation xi whole square.
मैम बेसिकली वेरिएंस डिराइव करते हुए जो सैंपल का वेरिएंस होता है वो हमें खुद से अज्यूम करके चलना है कि वो सिग्मा स्क्वायर बाय एन ही होगा.
नहीं, वो सिग्मा स्क्वायर बाय एन होता है.
मैम होता है, बट
इसका डेरिवेशन है ये वाला. What we have is xi's are independent, है ना?
Yes ma'am.
Now variance of x bar would be how much? Variance of 1 by n summation xi. Now कोई भी कोएफिशिएंट हो अगर रैंडम वेरिएबल के साथ, then this is a property of variance कि variance of ax will be a square into variance of x. उसी लॉजिक से when I have, let's say this is my random variable, some random variable y, so then variance of ay will be a square into variance of that random variable y.
Okay ma'am.
Okay, अब यहाँ तक हो गया. Now variance of summation xi. Variance of summation xi, if I have to write it, this is analogous to a plus b whole to the power n, a plus or summation ai whole square. It is very analogous to this thing. This one is actually variance of xi square plus double summation I equal to 1 to n, j equal to 1 to n, I not equal to j, covariance of xi into xj. This is the generalized formula. Okay. Now, when xi and xj are independent, then they are uncorrelated as well, and that is why the covariance terms between xi and xj becomes 0. So when all xi's, so this is pairwise, all of them pairwise are independent to each other. Okay, none of them is related to any other. So all these covariance terms will be 0 because it is given xi's are a random sample. Xi's are IID if you see, or if you see it is given it is a random sample. It means that all xi's are mutually independent. Okay. Whatever is the value that xi is taking, x1 is taking, is not dependent on any of the x's. For example, let's say tossing of a coin. You are tossing a coin n times, and xi is the, if it is head or tail in ith trial, if this is your experiment. So what comes up in first trial or first toss is independent of what comes up in your third toss or what comes up in your 10th toss. All of these are independent. It does not depend on what has come previously, right? So similarly, variance of summation xi, we'll have this one, and since xi's are all independent among themselves, this covariance term will be equal to 0. So when this part vanishes, we don't have this part, then this we can write as variance of summation xi equal to summation of variance of xi. Okay. So now variance of xi we already have. It is given by sigma square. Okay, so we have summation sigma square I equal to 1 to n. So sigma square we are adding it n times. So here we will have sigma n into sigma square. And previously, by virtue of this coefficient a square variance of y, we had 1 by n square. So this part then is n sigma square, and thus variance of x bar becomes sigma square by n. Is this clear now?
Yes, ma'am.
Okay, but still I think you are not convinced. What is your exact doubt? Can you please tell me?
मैम कोई और एग्जांपल अगर आपके पास में हो तो एक और क्वेश्चन सॉल्व करके दिखा दो.
With respect to unbiasedness?
यस मैम, बट वेरिएंस का मैं मीन का निकाल पाता हूँ, मेरे से वेरिएंस का नहीं निकल रहा है.
Okay. On the fly it is difficult to construct. Let me see if I have something like this. Let's say actually here I have not assumed any distribution. Anything if you want of this sort. Okay. Let's say mu square. Let us try to find out expectation of some function of x bar equal to mu square. Okay, so x bar, it follows mu sigma square by n. Okay, now variance of, let's say, x bar is sigma square by n, so we can write it as expectation of x bar square minus expectation of x bar whole square equal to sigma square by n. So expectation of x bar square equal to sigma square by n plus mu square. Okay, now Now this one also, we know expectation of s square is this thing. So let's say expectation of x bar square minus s square by n equal to mu square. Okay. So these are like constructed with examples, like whatever I solved with sigma square. Give me some more time. I will try to find out another example with sigma square and then give you that, because this is like going back and forth, not very useful. Basically any expectation that you are given, you're asked to find out whether it is unbiased or not. You just have to do an expectation of gt if it equals to theta. That's all. And then you have to use several results to obtain that. Okay. I think where you are confused is that directly you are saying that since x bar expected value of x bar is mu, maybe expectation of this thing should also be equal to sigma square, because mu is an estimate of x bar. But then we cannot do that because because of this concept of degrees of freedom. Okay, so we are, by estimating mu, which is which is sort of used in the formula for sigma square, we are losing out on 1 degree of freedom. That is why we have this n minus 1. Okay, that's the intuitive logic behind having it as n minus 1. But okay, I'll try to find out another example with this sigma square and give you the results. Okay, is that okay? But this problem you understood how to solve, right?
Yes, ma'am.
Okay, thank you so much. So point that you need to note is this these results are very, very important. Okay, and this holds true for any distribution regardless of your distribution. Null assumption. Okay, if you have xi as IID, it follows some mu and sigma square, then x bar, mean of x bar will be the same mean, and variance will be sigma square by n. Alright. Okay. Any other question from week 10 assignments that you want me to discuss? Week 10, week 9, anything?
No, ma'am.
Okay. Could you solve question 11 from last week's week 10's? Because that is quite similar to the question that you asked. You didn't have any problem solving question number 11, did you? Where x bar, assuming sigma square to be known, let x bar be
Please
this.
explain question 11 as well.
Okay, fine. But were you able to solve this?
Yes, ma'am, I have done it, but just for clarity, I want you to.
Alright, okay, fine. So here, this is question 11. So the question was same thing, x1, x2, xn follows normal with mu sigma square.
Hello.
Hello?
Hello.
Hello?
Ma'am, please also explain some questions regarding to 11th assignment.
Regarding which one?
11th assignment.
11th assignment. Okay, fine. Okay, so this was question number. We had sigma square known and x bar is 1 by n summation xi. So we had to find out an unbiased estimator for mu square. Okay, so x bar also follows normal mu sigma square by n. So variance of x bar is sigma square by n. This we can write as expectation of x bar square minus expectation of x bar whole square equal to sigma square by n. Expectation of x bar is mu square, so we can write expectation of x bar square minus mu square equal to sigma square by n. So from here, since sigma square is known, if we write expectation of x bar square minus sigma square by n, we have mu square. Okay, and for 2 mu square we should have 2 x bar square 2 sigma square by n. Now this is my required tx, that is 2 x bar square minus 2 sigma square by n. This is a statistic only because sigma is known. Alright, it is not dependent on any parameter. Sigma is known means sigma is fixed, 1, 2, 3, whatever be it. Alright, if it was the case that sigma is unknown, then using the results that we just obtained, expectation of 2x square minus 2s square by n would be equal to 2 mu square. Is it okay? So the answer would be 2x bar square minus 2 sigma square by n. The intuitive logic is, if we want to have a mu squared term, then we should try to tackle it using variances. Is it clear?
Yes, ma'am.
How did you do it? Did you do expectation of all the options, and then you found out?
No, ma'am, your way.
Okay, fine. Alright, so if nothing from the previous assignments, then let us try to solve a few questions based on this assignment. Okay, so the question is, let x1, x2, xn be a random sample from population with normal distribution with population mean mu and variance sigma square. Assuming sigma square to be known and let x bar equal to this thing, suppose there are three estimators, x bar by root n, x bar by n square. Then which are consistent estimators of mu? So in order to find out consistency, there are two criterias. Consistent means unbiased. Okay, expectation of t should be equal to our parameter of interest theta, and variance of t should be close to 0 as n tends to infinity. Okay, these are the two criteria that we should take care while finding out consistency. So then our mu1 hat estimator is x bar. So let us find out expectation of mu1 hat. So expectation of x bar will be how much? Since it is normal, it will also follow normal, mu and sigma square by n. This we have already seen. Okay, so expectation of mu1 hat will be mu, and variance of mu1 hat will be sigma square by n. That goes to 0 as n tends to infinity. Because sigma square is finite, if n is very large, let's say 1 trillion, 10 to the power 10 trillion, then this fraction will be very small and this variance term would go to 0. So this is meeting our consistency criteria, therefore mu1 will be consistent. Okay, let us try with this one, x bar by root n. Okay, mu2 hat is x bar by root n. The expectation of mu2 hat will be 1 by root n expectation of x bar. Okay, so then this one will be 1 by root n into mu. Okay, so this is not equal to mu. So this is not unbiased. So then we have to resort to some other methods. This one was, what do I say? This one was, this is a biased estimate. So then what we have to find out? We have to find out that the MSE should go to 0. Okay, so how do I find the MSE? So MSE is 1 by n x bar minus theta. Sorry, MSE will be mean squared error, no? So this is actually variance of theta hat plus bias of theta hat square. Okay, so variance of theta hat is how much? Theta hat is by root n, and bias is how much? Bias is expectation of mu2 hat minus mu. So this will be 1 by root n mu minus mu. So this will be 1 by root n mu minus mu whole square. Okay, so this will be 1 by n variance of x bar plus 1 by n mu square plus mu square minus 2 by root n mu into mu. Okay, so this will be 1 by n into sigma square by n plus this will cancel out, so we'll have mu square, sorry, this would be plus mu square plus 1 by n mu square minus 2 by root n mu square. Alright, so as n tends to infinity, this term will go to 0, this will go to 0, and this will also go to 0. So then MSE is going to tend to mu square and not 0. Therefore, mu 2 hat is not consistent. Okay, let us move to mu 3 hat, x bar by n square. So x bar by, what was this, n square. So here also expectation of x bar by n square will be how much? This is mu by n square. So bias is how much? Bias is mu by n square minus mu. Alright. Now MSE of mu 3 hat is variance of mu 3 hat plus bias square. So this will be variance of mu 3 hat will be variance of x bar by n square plus mu by n square minus mu whole square. Okay, so how much does this come to? So then this will be this will be variance of x bar by into the power 4 plus mu square by n square. So this will be mu square by into the power 4 minus 2 mu square by n square plus mu square. So this will go to 0, this will go to 0, this will go to 0, but the overall it will go to mu square and not 0. Okay. Okay. So where were we? So also one more thing that we can check here is that it converges in probability to the true parameter of interest. So then what we have to find out is probability x bar minus mu greater than infinity, this goes to 0 as n tends to infinity. So probability were you taught about inequalities?
Ma'am, please explain it.
Were you taught about inequalities like what do I say? Markov's inequality or Chebyshev's? Were you taught about this?
Yes, ma'am. Chebyshev, I think I have.
Markov's?
No, ma'am.
Okay. So Markov's uh, inequality is that if you have a non-negative random variable x, then probability x greater, if x is non-negative, that is greater than equal to 0, then x greater than equal to a should be less than or equal to expectation of x by a. Okay, and Chebyshev's inequality states that probability x minus special case expectation of x greater than equal to k is actually less than equal to variance of x by k square. Okay, so we'll just verify whether this holds or not, because here whatever we are checking consistency, we are checking it with respect to expectation of x. Okay, so this one, let's say probability mu1 hat minus mu. Okay, so greater than equal to k is less than equal to variance of mu1 hat by k square. So this is equal to mu1 hat was variance of x bar by k square, and k is any positive number. So this goes to 0 because this is equal to sigma square by n k square, which goes to 0 as n tends to infinity. Therefore, we can say that mu1 hat is consistent for mu. Okay. But then this will not hold for the others. So then if here we have probability of this one, mu2 hat. Mu2 hat is how much? Mu2 hat is x bar by root 10. X bar by root 10 minus mu. If it is greater than or equal to epsilon. Should be less than or equal to expectation of x bar by root 10 minus mu whole square by k square. Okay, so this should be equal to expectation of 1 by n x bar square minus 2 mu x bar by root 10 plus mu square by k square. Yeah, this will not go to 0 as n tends to infinity. So it's not a consistent estimator. Alright.
मैम बेसिकली कंसिस्टेंसी चेक करने के लिए हमें MSE निकालना है.
हाँ, basically we have to prove this thing. Consistency निकालने के लिए कि probability theta hat minus theta greater than epsilon, this should tend to 0 as n tends to infinity. But sometimes people will usually take a call using only variance property. I am not so sure how correct is that. Just okay, let us proceed to the next definitions. This thing is very clear. If it is unbiased, if theta hat is unbiased, then consistency we can check using variance of theta hat should go to 0 as n tends to infinity. But what happens if there is bias? So when there is bias, to check for consistency, we should see whether MSE is converging to 0 or not. Okay. Alright, let us move on to the next one. Yeah, so let x1 and x2 be IID Poisson random variables. T1 equal to x1 plus x2 and T2 equal to x1 plus 2x2. Then which of the following are true? Both T1 and T2 are sufficient for lambda. Neither is sufficient. T1 is sufficient, T2 is not. T2 is sufficient for lambda, but T1 is not. Now what do we mean by a sufficient statistic? The main goal is to reduce the dimension and use one or a reduced metric to fully characterize, or the idea is to reduce the dimension without loss of information. Okay, so let's say if x1 x2 are IID Poisson, then x1 plus x2 will follow Poisson to lambda, right? So the information about the unknown parameter lambda, here we needed x1 and x2, two independent variables, were explaining some distribution of this, they were giving me some idea or estimate about the Poisson lambda, the parameter, unknown parameter of interest. But instead of that, if we just use x1 plus x2 by 2, this is just one variable. So this one variable is also following Poisson lambda. So what we are doing, instead of taking two independent variables, we can just, instead of characterizing a distribution using two variables, we can reduce the dimension by one, and that will explain the same thing. So there is no further loss. So this sort of statistic is usually called sufficient statistic. Okay, and the formal idea is that probability of given that sufficient statistic exists, so when we condition on the sufficient statistic, then probability of x1 or xn given t, this is actually independent of the parameter of interest, that is theta or lambda. Okay. Is it okay? So the conditional distribution of x1 to xn given t, it is, if it is independent of theta, it means that information about theta or the parameter of interest is already contained in this sufficient statistic. No other additional information is being conferred when we condition the distribution on the sufficient statistic. Okay, so this is the definition, and we are going to use this definition to find out whether these are sufficient or not. All right. Okay, so then here T1 will follow Poisson 2 lambda. So therefore probability x1 equal to x, x2 equal to y, given t equal to x plus y. Okay, this we can write as probability x1 equal to x, x2 equal to, or let's say here I'll write t equal to t. So x2 equal to t minus x is going to give you y, where t is x plus y. Okay, this divided by probability t equal to t. Is this okay? So since x1 and x2 are IID Poisson, probability x1 equal to x, x2 equal to t minus x by probability t equal to t, this will be given as probability x1 equal to x into probability x2 equal to t minus x by probability t equal to t. So x1 follows Poisson lambda, so this will be e to the power minus lambda, lambda to the power x by x factorial. This was also e to the power minus lambda, lambda to the power t minus x by t minus x factorial, by this will be e to the power minus, this is x1 plus x2 would follow Poisson 2 lambda. So minus 2 lambda to the power t divided by t factorial. So e to the power lambda here, minus 2 lambda, these will cancel out. This we can write as t factorial by x factorial into t minus x factorial, lambda to the power t, lambda to the power x minus lambda to the power t will be separate, and this will cancel out with this lambda to the power t. Lambda to the power x and lambda to the power minus x will cancel out, so we'll be left with 1 by 2 to the power t. So this is tcx half to the power t. Alright, and this is independent of lambda. So this implies t is sufficient. Is it okay? Any doubt? Okay. So if I move on to the next one, T2 equal to x1 plus 2x2. So let us see what is the distribution of T2. T2 is x1 plus 2x2. Alright. So let us assume let this be. So probability x1 equal to x, or rather I'll write it like this, probability x2 equal to x, x1 equal to t minus 2x by probability t equal to t. Okay, so this one same thing we'll write, e to the power minus lambda t minus 2x, lambda to the power t minus 2x by t minus 2x factorial into e to the power minus lambda x, sorry, extremely sorry. This would be e to the power minus lambda t minus 2x, sorry, lambda to the power t minus 2x by t minus 2x factorial into e to the power minus lambda to the power x by x factorial by to the power minus lambda to the power t by t factorial. Okay, so same thing, e to the power, this will be 2 lambda, sorry, this will be t2 is x1 plus 2x2. 2x2 follows Poisson 2 lambda and x1 follows Poisson lambda. So total this will be Poisson 3 lambda. Alright. So this one, this will be the power minus 3 lambda, lambda 3 lambda whole to the power t by t factorial. Okay, so here this will be 2 lambda, this will be 2 lambda to the power x by x factorial. So 3 lambda will cancel out. We'll have lambda to the power t, lambda to the power 3 will also cancel out. We'll have lambda to the power minus 2x plus x. So we'll have lambda to the power minus x, and here we'll have t factorial by t minus 2x factorial into x factorial. So you see here this is dependent on lambda. Lambda term is not vanishing. Alright, therefore this is not sufficient. Okay, so let us take any example of this T2. So let's say x1 is 0 and x2 is 1. So T will be x1 plus 2x2, so that will be 2. No other combination is going to give me T equal to 2, right? So if we want to find out probability x1 equal to 0, x2 equal to 1, given t equal to 2, then we have to write x1 equal to 0, x2 equal to 1 by probability x1 equal to 0, x2 equal to 1, and also another combination is going to give me t equal to 2, that is x1 equal to 2 and x2 equal to 0. Alright, so then this we can write as probability x1 equal to 2 and x2 equal to 0. Alright, so then this will be probability x1 equal to 0, x2 equal to 1 by x1 equal to 0 into x2 equal to 1 plus probability x1 equal to 2 and x2 equal to 0. Okay, so if we just solve this, so what I am trying to say is that either you can give a generalized proof or you can give one counter example. Okay, so if it doesn't hold for one value, then it will not hold for, it is not true for all values. Okay, so these are the two ways by which you can tackle such problems which asks whether this is sufficient or not. Okay, so this is one such counter example. So if we want to find out given t equal to 2, it could be either this condition or it could be either this condition. So now if we just solve this, we'll have e to the power minus lambda, lambda to the power 0 by 0 factorial into e to the power minus lambda, lambda to the power 1 by 1 factorial by e to the power minus lambda, lambda to the power 0 by 0 factorial into e to the power minus lambda, lambda to the power 1 by 1 factorial plus the other combination, x1 is 2, x2 is 0. So if x1 is 2, we'll have e to the power minus lambda, lambda square by 2 factorial into e to the power minus lambda, lambda to the power 0 by 0 factorial. So here again e to the power minus 2 lambda will cancel. Here we have 1 into lambda by, here we have lambda to the power 0 is 0, this is also lambda, plus this cancels, we'll have lambda square by 2. Okay, so we can write as 1 by 1 plus lambda by 2. Okay, which is dependent on lambda, therefore not sufficient. Okay, if this what will be the distribution and what is the, if this becomes too complicated, just take one example. Okay, you fix t at any given point, find out what are the possibilities of t x1 and x2 that you could take. So probability this given t equal to 0 is that probability of the numerator by probability t equal to 2, which can arise due to several combinations. List the combinations out, find out the probability, and if that depends on lambda or your parameter of interest, that is theta, then you say that this is not sufficient. Is it okay? Okay, the consistency examples that I was giving, alright, we'll come back to this thing. Let us find out this one. Okay, so the question is, let x1, x2 and xn be a random sample from exponential distribution, and suppose these are the two parameters, then which is the consistent estimator? So how do we do this? Expectation of x bar is how much? This is 1 by n summation expectation of xi. Expectation of xi from this thing is how much? This is theta. So this will be 1 by n summation theta. So will be theta. So this is actually unbiased. So now if this is unbiased, then variance of x bar is equal to 1 by n square summation variance of xi. Now variance of xi is theta square. Okay, so this will be 1 by n square summation theta square. So this will be theta square by n, which goes to 0 as n tends to infinity. Therefore theta 1 is consistent.
Ma'am, it is theta square by n or n square?
Theta square by n. This is an
Ma'am,
exponential distribution, no? So expectation of xi will be, since this is one, whatever is the parameterization, if this is 1 by theta e to the power minus x by theta, then this will be 1 by 1 by theta. So that is theta. Okay, and variance
okay.
of xi is 1 by 1 by theta square. So that is theta square.
Oh, ma'am, that n square comes to n.
This part,
That's why I'm asking. Last part.
this is that same thing. See, variance of x bar means what? This means variance of 1 by n summation xi.
Hmm.
So 1 by n will come out as 1 by n square. Then since xi's are independent, it's given random, we'll write it as summation variance of xi. each xi is theta square. So this will be 1 by n square summation of I equal to 1 to n theta square. Theta square repeated n times. So this will be n theta square by n square. So we'll have
Okay.
so that's how we'll have theta square by n.
Okay, ma'am.
Okay, here
Got
this
it.
theta square is actually the sigma square that I was talking about.
Okay.
Alright. Okay, so this is there, and also for this one, variance of theta 2, sorry, but theta 2 is not biased. Here I have confusion what to do if there is bias in the estimator. So for bias, the usual way to go about is calculate the MSE. So as n tends to infinity, if bias is going to 0 and the variance is also going towards 0, then we say that that is a consistent estimator. But sometimes people would only check variance, but that is not the correct thing to do, but it is sometimes done. So I'm thinking what we should do.
Ma'am, assignment 11 question are a little bit tough. It is not solving.
Which one uh, are you not able to solve? So you learnt about the factorization theorem for
Um,
sufficiency.
yes, ma'am. Sufficiency. Learn about sufficiency and
Okay.
uh,
So
estimator.
let's say this is your one of the assignment questions.
Okay.
Okay. So here what you have to do is I will not solve this now, but I'll give you a hint. This one you write as per the factorization theorem. So you find out the joint PDF or joint PMF. Okay, and then try to imply what could be the sufficient statistic using the factorization theorem. So if I have to write down that fx1 to xn, this would be theta to the power xi, or rather theta to the power xi into 1 minus theta to the power 1 minus xi, product I equal to 1 to n. Okay, so
Ma'am, please solve some practice questions related to assignment 11 so that it could be help us for solving such questions.
sufficient estimator. Okay, I won't be able to solve it right now, like the assignment questions per se, but I can solve similar questions.
Yes,
Okay.
ma'am. Please solve similar
Yeah.
questions.
Okay.
No, not exact that questions. Practice question I'm
All right.
asking.
All right. Let's say this question. Okay. So this one is that an engineer is measuring a quantity theta. It is assumed that there is a random error in each measurement. So the engineer will take n measurements and report the average of the measurements as the estimated value of theta. Here n is assumed to be large enough so that central limit theorem applies. If xi is the value that is obtained in the ith measurement, we assume this thing. If we assume wi is our iid, then what should be n such that this holds? Okay, this is a question from interval estimation. All right.
Yes, ma'am.
Okay, so now what is it given? Okay, so x bar is 1 by n summation xi. So this is 1 by n summation theta plus wi. Alright. So this one we can write it as theta plus 1 by n summation wi. Okay. So now this one we can write that expectation of, from here we can write expectation of xi equal to theta. Okay, and variance of xi is variance of wi, that is 4. Okay, because theta is fixed but wi is the random variable. Okay, now here we have to find out this probability x bar so we can rephrase this like x bar minus theta less than equal to 0.25 less than equal to minus 0.25 greater than equal to 0.9. So the question is, how large should n be? So if we transpose this, then theta is less than equal to x bar minus 0.25 and less than or equal to x bar plus 0.25. Okay, so the question is, how large should n be such that this thing holds? Okay, so now 90% or confidence interval for theta, assuming normality. Okay, so we assume xi's are normal variables. Okay, then since the variance of xi is known, therefore a 90% confidence interval is actually given by x bar minus, this is your z alpha by 2, that is here your alpha is 0.1, so this will be z alpha by 2 sigma by root n, and this should be x bar plus z alpha by 2 sigma by root n. Alright, so what is the so here by parity this value should be equal to 0.25. So z alpha by 2 sigma by root n should be equal to 0.25. Alright, so sigma is 2 because sigma square was 4 and alpha is 1 minus 0.9. So alpha by 2 is 0.05. So z 0.05 is that point such that this is a normal distribution, normal 0 1. Then this is z 0.05 such that the area above this point is 0.05. So for a normal distribution this point is 1.64. Alright, so here this would be 1.64 into 2 by root 10 equal to 0.25. So if we write root 10, that will be 1.64 into 2 by 0.25 and n would be 1.64 into 2 by 0.25 whole square. Okay, whatever will it be, the closest integer greater than or this n is that value of x which will result in this confidence interval. Okay, all right, moving on. So let x1, x2, xn be a random sample from a geometric distribution where theta is unknown. Then how can we find the MLE or maximum likelihood estimator of theta based on this random sample? Okay, so then fxi, this we can write as what is the PDF. So PDF considering x to be the number of trials, this would be this. Okay, geometric theta. So fx is 1 minus p whole to the power x minus 1 to the power into p. X minus 1 failures and then xth trial yields a success. Okay, so then the likelihood x1, x2, xn would be actually the joint PDF of x1, x2 and xn. So this would be 1 by theta to the power x1 minus 1 into theta into 1 by minus theta to the power x2 minus 1 into theta and so on, 1 minus theta into xn minus 1 into theta. Okay, so this one is actually 1 minus theta summation xi minus n into theta to the power n. Okay, so this is the likelihood function. So for in order to find the MLE, first step is write down the likelihood function. Then the next step is step 2 is to write down the log likelihood. Okay, so then step 2, how will we write? This we'll write as log of L x1 xn. Okay, so then this would be summation xi minus n log of 1 minus theta plus n log of theta. Okay. Then the next step, step 3, is differentiate the log likelihood with respect to theta and equate it to 0. So if we do that, we'll have summation xi minus n by 1 minus theta into minus 1 plus n by theta equal to 0. So if we solve this, we'll have n by theta equal to summation xi minus n by 1 minus theta. Okay, so then we'll have this as 1 minus theta by theta equal to summation xi by n minus 1. Okay, so this would be 1 by theta minus 1 equal to summation xi by theta minus 1, sorry, by n minus 1. So theta hat MLE is actually n by summation xi. Okay, if you want to check, then if you double differentiate this log likelihood before equating it to 0, if you double differentiate this thing, d theta square, this quantity, let's say this is y, this would have been less than 0 at theta equal to n by summation xi. Okay, so this you can check, this would come. So then if we equate it to 0, this is actually the MLE, n by summation xi. Is it okay?
Yes, ma'am.
All right. Now this is another example. Let x1, x2, xn be a random sample from uniform 0 theta. Find the maximum likelihood estimator of theta based on this random sample. So here also, if I just write the likelihood, this will be 1 by theta into 1 by theta into 1 by theta n times when 0 less than equal to x1 less than theta, sorry, yeah, so for all x1, x2 this holds, okay, and 0 otherwise. So this likelihood is actually 1 by theta to the power n if 0 less than equal to x1, x2, xn less than equal to theta and 0 otherwise. Okay, now from here we have to note that this is a decreasing function of theta. So as theta increases, this likelihood is going to decrease. Okay, so therefore the maximum likelihood will be obtained when we have minimum theta. Okay, and what is the range of theta? 0 less than equal to xi less than equal to theta. So therefore theta has to be greater than equal to x1, x2, xn, all the x's. So this is equivalent to, if theta is greater than maximum of the x's So if theta has to be minimum, and the lowest it can go is up to maximum of x1 to xn. Therefore, theta MLE would be maximum of x1, x2 to xn. Is it clear? Okay, so let me move on to the next one then. So here the question says that I have a bag that contains 3 balls. Each ball is either red or blue, but there's no information in addition to this. Number of blue balls, it can be 0, 1, 2 or 3. If I am allowed to choose, if I am allowed to choose 4 balls at random from the bag with replacement, okay, and xi is 1 if the chosen ball is blue, xi is 0 if the chosen ball is red, okay, and xi follows Bernoulli theta by 3. And after the experiment, it is observed that the values of xi's are this. So for each possible value of theta, find the probability of the observed sample 1011. For which value of theta the probability of the observed sample is largest. Okay. So here success probability is theta by 3. Okay. So this is, if I have to write the probability is theta by 3 if x equal to 1 and 1 minus theta by 3 if x equal to 0. Alright. So then probability of x1, x2, x3, x4, since all are independent, would be given 1, 0, 1, 1, that is theta by 3 to 1 minus theta by 3 into again theta by 3 into theta by 3. Okay. So then that probability is actually theta by 3 cube into 1 minus theta by 3. Okay. So when this is the likelihood function. Okay. So that will evaluate at theta equal to 0, theta equal to 1, theta equal to 2 and theta equal to 3. So for 0 and 3 this will be 0 and 0. For 1 and 2 we will substitute here and find out the values. And whichever theta is yielding the highest likelihood, that is the maximum likelihood estimate for theta. Okay. So if this is the likelihood, what we can do is just find out log L differentiate with respect to theta, equate to 0, and then whatever is theta hat, that will be my theta hat MLE. Is it okay? Alright. So this is another interval estimation. Okay, so if you have a random variable given from a distribution with known variance, and this is the sample mean, how to find a 99% confidence interval. So same problem as this thing. Okay, so here the question is, here you have n and this is your sample variance. Okay, 95% upper bound for variance is actually formed by your chi-square distribution. So n-1 s square by sigma square will follow a chi-square n-1 distribution. Okay, so you have to write n-1 s square by sigma square less than chi-square n-1. This, if this is a chi-square distribution, let's say this point is chi-square 1 minus alpha by 2, and this point is chi-square 1 minus, sorry, this is chi-square alpha by 2. So this alpha that you need to take is 0.05. Okay, so then here this area will be 0.025, this area will be 0.025. So using the software or the table, you can get these peak points. Alright, so get these. This probability will be 1 minus alpha, that is 95%. Now once you obtain these values, just do a transpose. So then your sigma square less than n-1 sig s square by chi-square 1 minus alpha by 2 into n-1 degrees of freedom, and this would be n-1 s square by chi-square alpha by 2. Okay, so since they are asking for 95% confidence upper confidence bound, then they are only asking for a upper confidence bound. Okay, so if they are asking for an upper confidence bound, then that should be this thing. Sorry. Alright, so then after you do transpose, sigma square will be less than whatever n-1 s square by this value, that will be your answer. Is it okay? So
हम जो भी वैल्यू आएगी, हेलो, हम जो भी वैल्यू आएगी,
हाँ,
तो सिग्मा स्क्वायर उससे बड़ा होगा या छोटा होगा, वो कैसे पता चलेगा?
see here sigma square will always be 0 greater than 0 and less than equal to some value. Okay, so here since they are asking for a upper confidence bound, sorry, here you shouldn't take out a two-sided intervals. What you should do is this equation that you have found out, this one you have, okay, this follows a chi-square n minus 1. So now taking motivation from here, if this is your chi-square distribution, then n minus 1 s square by sigma square less than equal to this area. Let's say this is chi-square n minus 1 alpha. What is this area? Above area is 0.05% and below area is 0.95%. Okay, so if you find out this one and if you write n minus 1 alpha, this is also you're 95% confident that this quantity is less than equal to this thing. Alright, so if you do a transpose, you will have a confidence that sigma square is greater than or equal to this much with a confidence of 95%. Okay, but you're not asked this, you are asked the upper confidence bound for sigma square. So then what you have to consider is you have to find out n minus 1 s square by sigma square should be greater than equal to chi square 1 minus alpha. This probability is 95%. Then you can be sure that n minus 1 s square by chi square 1 minus alpha, this is equal to 0.95. So then this is an upper bound for sigma square. And how will you find this? This is that point in the chi-square spectrum such that this above area is 0.95. Okay, so once you get this, that will give you the upper confidence interval for sigma square. Is it okay? So here, as you can see here they are given two-sided 95% confidence interval for mu. Okay, so then here you would have to find out mu less than equal to and greater than equal to, and then that probability should be equal to 0.95. Okay, So try out the, so if you are to find out the method of moments estimator, just equate the x bar with your method of moments estimator. Okay, so x mu is the first order moment, right? And variance, variance is the second order moments. Okay, so just find them out. So whatever will be your mu1 prime equate to x bar. If you have two parameters, then mu2 prime with some other, let's say.
मैम ये वाला क्वेश्चन तो हो गया था असाइनमेंट का.
Okay.
जो काई स्क्वायर वाला था और जो टू साइडेड 95% वाला था उनमें प्रॉब्लम आ रही थी. तो अगर आप एक बार वो वाले सॉल्व कर देते तो मैम.
काई स्क्वायर वाला तो मैंने हिंट दे दिया ना, तो आप इससे सॉल्व कर लीजिए. ओके So similar questions are these. So if a farmer weighs, let's say, 10 randomly chosen watermelons, weight is normal distribution with mean mu and variance sigma square, 95% confidence interval for mu, mean, given variance is unknown, that would be x bar minus t distribution. Okay, and this would be t alpha by 2 sigma square by root 10 less than equal to mu less than equal to x bar plus t alpha by 2 sigma square by root 10. So this one and this one, where alpha will be 0.05 and this is n minus 1 with degrees of freedom n minus 1. Okay, so whenever you have a normal distribution with known mean and unknown variance, with unknown mean known variance, then you have to apply the z-score. Okay, so then that would be x bar minus, usually if it is 95%, then that would be z alpha by 2. Okay, or let's say that point, critical point, such that above area is alpha by 2. So z alpha by 2 sigma by root 10 and x bar plus z alpha by 2 sigma by root 10. This would hold true given that sigma is known. Okay, if sigma is not known, then your would be x bar minus t, it would become a t distribution, alpha by 2 with degrees of freedom n minus 1 sigma by root 10 and x bar plus t alpha by 2 n minus 1 sigma by root 10. This becomes not sigma but s by root 10 when your this is unknown, when sigma square is unknown. Okay, so S, how will you calculate? S is that 1 by n minus root over 1 minus n minus 1 summation xi minus x bar whole square. This is the alpha or 1 minus alpha % confidence interval for mu. Okay. Alright, are there any further questions from today's session?
हम कंसिस्टेंसी समझा दो एक बार फिर से.
Okay, consistency in order to prove anything is consistent, you have to show this theta hat minus theta greater than equal to epsilon, it goes to 0 as n tends to infinity. Okay, this is the thing that you want to show. Now if theta hat is unbiased, then expectation of theta hat is equal to theta. Then if variance of theta hat goes to 0 as n tends to infinity, we say that theta hat is consistent. Okay, but if theta hat is biased, then what we need to check is that here I have a doubt. It could be that the variance of theta hat is going to 0, but if bias is not going to 0, I don't know whether we should call this as a consistent estimator of theta or not. Okay, so maybe I'll consider a few textbooks to find out what to do if theta is if theta hat is unbiased. Okay, so the idea is that theta hat should tend to theta as n tends to infinity, and the variation should be very 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 low. The best way to go about this problem is to try to show this definition, that this goes to 0 as n tends to infinity, or in other words, probability theta hat square minus theta square less than, this one is less than equal to expectation of theta hat minus theta whole square by epsilon square. and show that this goes to 0 as n tends to infinity. Okay. All right. So okay, I'll do one thing. I'll clear this confusion. Give me 1 or 2 days. Okay. When is the last date of submission for this assignment?
Wednesday.
Wednesday. Okay. All right. So keep an eye out on the discussion forum. Okay. I will clear this doubt and post a write-up if possible, in order to clarify what happens when we have bias in the data. Okay, with 1-2 examples, so that it is easier for you to understand and solve the questions. All right, because some people, they just look at the variance irrespective of whether they are unbiased or not and comment that this is consistent. Okay, so what happens in this special case when bias is not equal to 0 and but the variance is tending to 0? This thing, just give me some time, I'll clarify this and I'll post it in the discussion forum. All right, I am also confused now. Is it okay?
Yes, ma'am.
Okay. So thank you so much for joining, and if there are further questions, I will explain that in the next class. Okay, thank you so much.